Hello and welcome back. In this last video of section 15.1, I want to talk about generalizing this idea of level curves and graphs of functions of two variables to functions of more than two variables, three variables, four variables, and try and give us a way to visualize those objects that we can't really visualize because we don't live in a four-dimensional world, or at least not four physical dimensions or five physical dimensions. So it's really hard to visualize those things. But we now have tools to help us understand functions of, say, three variables or four variables. So remember, a function of two variables, if I just have x1 and x2 here, which we call x and y, then z is our third one, and we're living, the graph of that function of two variables lives in three-dimensional space, right, as a surface. So if I add a third variable to this, x1, x2, x3, and then I let my output be, say, x4, that will live in four-dimensional space. That graph will live in four-dimensional space as a volume, right? As a three-dimensional object in four-dimensional space. For two variables, function of two variables, we had a two-dimensional object, a surface, inside of three-dimensional space, and we keep going from there. Then we'll have a three-dimensional object inside of four-dimensional space. For a function of three variables, a function of four variables will be a four-dimensional object living inside a five-dimensional space. Those things are going to be really, really difficult to visualize. So we'll kind of focus here, at least in this video, on functions of three variables, which live in four-dimensional space, and their volumes inside a four-dimensional space. So the domain of a function of three variables would be a volume, a set inside of R3. In general, it's a set inside of Rn. And then the range is always a set of real numbers, right? The range is always just along one axis. Okay, so how do we understand these? And at least for functions of three variables, how do we understand what a four-dimensional graph looks like? Well, what we do is we extend those ideas of level curves to level surfaces. So here's what I mean by that. So here's a function of three variables. Again, the graph of this thing lives in four-dimensional space. And if I fix my outputs, heights in heavy quotes, because we can't really make sense of heights anymore in four dimensions. But if I fix my output, I'll get out surfaces. So like when we did level curves of graphs of functions of two variables, we got curves. If I jump up a dimension, I'm going to get surfaces for each of my levels. So in this case, so let's see a domain. Let's do a domain here. So domain of this function. Same things work here, right? We just want whatever inside of the square root, we want this to be non-negative. So we need 25 minus x squared minus y squared minus z squared to be greater than or equal to 0. So that tells me that x squared plus y squared plus z squared must be less than or equal to 25. And what is this? Well, if it were just x squared plus y squared plus z squared equal to 25, that would be a sphere of radius 5. Since this is less than or equal to, we're talking about all the space inside of and including the sphere of radius 5. That is a ball. So this is a ball of radius 5. So that's the domain of this object, is everything within a ball of radius 5 centered at the origin. So we could graph that domain, imagine that ball. At every point in that space, there's some function value assigned to that point. Since our domain's in three dimensions, how do we really put that other axis? We need a fourth dimension for that, and this is where things get hard to visualize. However, we can still graph level surfaces of this. So if I fix w equal to some constant, so I'll set w naught equal to square root of 25 minus x squared minus y squared minus z squared. I'll square that. I'll add w squared. Add that over. I'm going to get x squared plus y squared plus z squared equal to 25 minus w squared. And so this is a sphere, right? I should get a surface out, a sphere centered at the origin still, of radius square root of 25 minus w naught squared. So that is, as the heights, again in air quote, increase, my radiuses are getting smaller. So as I move up, if I want to ascend my four-dimensional graph, or rather three-dimensional graph living in four-dimensional space, if I want to ascend that, then my radiuses of these balls or of these spheres get smaller and smaller and smaller. So my level surface when W naught is equal to 0 would just be the sphere of radius 5, but in general they're spheres of varying radiuses. So again, this takes some time and some work to try and visualize this three-dimensional object living in four-dimensional space that is the graph of this function. But through these level surfaces, that kind of aids us in that, right? It's still difficult. Don't trouble yourself too much if you're not quite visualizing it. It's impossible to visualize, but we can still better understand it. All right, that's it for this video, and that's it for this section. I'll see you in the next section.